Hey guys, welcome back to our second video tutorial on problem solving, where in our last video tutorial we started looking at what is an algorithm, and we did a simple example using a day-to-day type of problem that one would face within the home. And in that we saw Joe having the issue of his alarm clock not working, and then from there we were able to come up with an algorithm to solve that problem. So just to reiterate, an algorithm is a step-by-step guide or instructions that should be followed to solve a problem. Now we also want to identify two ways of representing an algorithm, and these are the two ways that we'll also be looking at throughout this series of instructions. So one of these ways that we can represent an algorithm is through the use of a flowchart, and the second method is through the use of what we call a pseudocode. Now, still observing on your screen, we realize that where a flowchart is concerned, it is a diagrammatical representation or a pictorial representation with the use of symbols in order to solve a problem. Whereas a pseudocode, it is giving us instructions in a step-by-step manner that we can be able to solve a problem, and later on we'll go into details as to how we are able to use these to solve problems in IT. But before we proceed to going in depth into these ways of representing algorithm, we are gonna be looking at a problem and then how we can simplify this problem by splitting it into smaller units with the use of an IPO chart. All right, so the problem is accept two numbers from a user to find their sum and to display the sum. And we said we are going to be using an IPO chart, which we will be breaking down the problem in a table format, right? So IPO chart, which represents three of the functions of the computer system. So the I stands for input, P stands for processing, and finally the O stands for the output. So we will then separate this problem into the different categories based on identifying what will be the input, processing, and the output stage. Now, based on the question or the problem that we have been provided with, we can identify that the input will indicate what is it that we will be collecting from our users. So we know that we will be collecting two numbers from whoever will be using the computer system, right? We also know that at the end of the problem solving stage, the user should be able to see the sum. So the computer would then display the sum to allow the user to see what the final number is. So currently we know what our inputs are and what the output is. So let's go ahead and see. So the first number, that would be an input. Again, input meaning that we are collecting from the user, and this is now going into the computer system. The second thing was not the second number, and in bracket you can see where it says num1 and num2. These are just names that we will use randomly. Instead of having to say 24, 35, etc., we just use a broad name called num1, which would represent any type of number that the user want to enter first. Same applies for num2 or num2, right? Output, we know that this is going to display the results of those two numbers that we collected, and again this would represent that this is the sum. So technically we now need to find out what is or what will be taking place when we collect the number from the user before they can get an output. So the processing would indicate that we would give the user a prompt, or in other words, we're going to display we're going to be asking the user to enter a first number as well as a second number, right? From here, what will happen when the user enter these numbers? How do we find the sum? So to find the sum, we know that the next thing in the processing stage would mean that we're going to be adding the first number to the second number. And then from here, the computer will now proceed to store the results of these numbers, which technically will be the sum. So this was one way of breaking down the problem into manageable parts that we can see and understand. And then using the same pattern, I will now proceed to show a second example using the IPO chart. So the first thing, in a real setting, the user would be prompted to enter the first number, right? So this is the processing stage thereabout. After they receive the prompt to enter the first number, the user would now go ahead and enter that number. So we would receive the first number. Following that, the user would receive a second prompt to enter another number, and then from here the number would be entered by the user. Once the user has entered both numbers that we asked for, the computer would now proceed to add in these numbers together and then store them. And finally, once all of this is completed, the user would now be able to see the sum as an output thereabout. So this is again breaking down our problem into smaller sections that we can understand, and then from there we can know how we would proceed to representing this in either a flowchart or a pseudocode. So now we will be proceeding first way of representing, which is our flowchart. Flowchart, as we recently discovered, is that it uses symbols, right? So there are some symbols that we will see when we are using a flowchart. One set is considered to be terminal. A terminal has two entities, one that represents a start of the flowchart or the starting stage of the problem solving process, and one which indicates an end, which tells us that our problem solving stage has been completed. So these we refer to as a pair, and they are called the terminal, represented by an oval. Second flowchart symbol is that of an or normally referred to as directional arrow, which indicates that this is used to connect each of the other symbols once we move throughout the flowchart. So we're flowing in a sequential manner then per se. So from step 1 to step 2, what we're doing first, moving to second, etc. Our flowchart directs us to each of these stages in the problem solving aspect. Third is our input output diagram. Input output diagram indicates that we can use this, and it is represented by a parallelogram, meaning that we can use this diagram whenever we're accepting from the user an input, or whenever we want to display a result to show the user at the end. And we just recently showed this in the IPO, where we had the first number that would have been an input, and then the output of the sum would have been an output. So this indicates that it is just the same diagram that they use to show that you have an input and you also have an output. And there is an example here which says read num, which would indicate that this was the first number that the user entered. And next symbol would be the process, and the process indicates that this is where our calculating aspect takes place, such as if we're finding sum, what formula will we use to find sum? So we know that sum would be the adding of numbers. If we were finding the product, then we know that the numbers would be multiplied by each other. So the process indicates that something or some calculations are being performed, and it happens using this symbol, and the symbol is either, the shape is either a rectangle or a square. And then our next symbol is a diamond, which represents a decision. So this indicates that if we are supposed to give the user a yes or no type of result, then a decision would be used. So let's say the user wanted to find out what would happen if the number 1 was greater than num 2. So the user wanted to say add another number if it is greater than 1. So if it was greater than 1, then it would mean a yes, and then here we would add a number. However, if it was a no, then the user could have asked to subtract from the number, and then we know that that would take place on that end. So the decision is either indicating if something is either true or false, or if we should proceed with a yes or no response. All right, so those were the flowchart symbols, and then these are what we will be coming across in our examples moving forward. Now we can go ahead using the previous problem. So we're solving the problem now in the format of a flowchart using those symbols. So previously we indicated that we begin our flowchart with the terminal, and this would be the one that says start, followed by our first terminal. We have our directional arrow, which indicates that we are now proceeding to another symbol in the flowchart, or it is directing us to something else that will take place in this problem solving stage. So following this, we would then prompt the user for 2 numbers, right? And then from there the user would enter the numbers. So the computer would now read the num1 followed by the num2 that the user entered. From here, again, connection with the flow directional arrow, and then once we get both the numbers from the user, we are supposed to find the sum, and this is where the process takes place, where num1 is being added to num2. Again, our directional arrow to say we're still solving some problems, so look forward to the next stage, which is the displaying of our sum. There was nothing else to take place in the process, so we would have our final directional arrow, and then we would proceed to our next terminal, which is to end the program, or this is where our problem has now been solved. So this is one way that we could solve the problem using the flowchart. A second way that we could have used is still the same process. There's a minor change. So we would prompt the user for a first number in this case, and then the user would then enter the first number. Once they enter the first number, we give them a next message to ask them to enter the second number, and again we would read the second number that they entered. From here, we would proceed to calculate the sum of these 2 numbers, because we did not ask for a third number, we only asked for 2 numbers. So we are now finding the sum of the 2 numbers, and then from here, we were expected to output the sum so that the user can see what the final value is. And the output sum was done, and finally we have completed our problem solving stage. So we have solved the problem, so we can proceed to end. We have completed the flowchart way of representing our algorithm, so we will now take a quick look at how we would implement a pseudocode to solve this very same problem. Now, a pseudocode is an English-like statement which imitates what an actual program would be able to represent and do. So for the pseudocode, we will solve the problem using little or minimal wording, and then from there able to follow those instructions to solve the problem. So we're proceeding with the pseudocode, and it is technically the same steps that we used in the flowchart. It is just that we don't have them in symbols, but they're actually in a sentence like structure. So the first thing that we have is the start of our program, or the start of our problem solving. And then from here, we would prompt the user for the first number. Once we prompt the user, the computer would then read that number that the user enter, and then from there we would now prompt for a second number. Second number, we prompt and give them the message to enter that number. Then the computer receive that number from them and read that into the computer to store. From here, the computer would now proceed to calculating these two numbers, and in order to calculate, because we're finding the sum, this means that we're going to be adding the numbers together. So the sum is equal to num1 plus, and then from here the user was supposed to see the results of the sum, so this is why we did an output of the sum. Finally, we have completed the problem solving stage. We don't have anything else. There was no other instruction, so we would then proceed to end our program. And this is just a quick way of producing our pseudocode. So on screen, we're seeing a comparison. For the flowchart, it is structured on a diagram, whereas the pseudocode, it is without the use of a diagram. Okay, thank you for watching, and please stay tuned for the other video tutorials.